So, hello everyone, welcome to my talk. Thank you all for coming. I know there's, like we said, a lot of interesting things going on here, and you came here, that's great. So, today we'll be talking about how to work with GraphQL services from F#, how to connect to them, how to get data and work with it. So, for today, we have a couple of sections we're talking about. First of all, I'm going to talk a little bit about myself. I'm going to get over that quickly. Then I'm going to talk about GraphQL services, because if you want to talk about them, we want to consume them, we want to know what they are first and what they bring to the table. I'm going to compare a little bit with REST APIs. I'm not going to talk about which one is better. They both have weaknesses and strengths, but I want to show by example if you don't know, so I will get that also quickly. We'll talk a little bit about what platforms are starting to use GraphQL and how they expose their data, and why GraphQL is a good decision for them. And then we will get to the good parts where we connect to GraphQL and show you how to do that from F# using a tool I've built called Snowflaqe. And then, of course, I'll show you how that works with a couple of demo applications. So we do a little prayer to the demo deities that they are on our site today. Okay, so a little bit of me. I'm from the Netherlands. I work there. I do everything that has to do with .NET and JavaScript, so C#, F#, wherever you call it. I do a lot of things that have to do with time series, so a lot of data to visualize, to analyze, and make nice graphs out of them. And then I do a little bit of open source work where I maintain and contribute to a bunch of libraries, one of which I'm going to talk about today. So, before we get started on consuming GraphQL services, let's talk a little bit about them and why they're so good. So basically, a GraphQL service is one endpoint on some backend, one HTTP endpoint on some backend that expects some query in like the request body, and based on the query, it will return some data. So instead of having a REST API with a bunch of data, a bunch of endpoints, you have one endpoint. You send it the query, and based on the query, you get the data. Okay, so it has a bunch of cool stuff. Instead of reading it out, I will just go through each part and talk by example. So the first part is that GraphQL is a query language for your data. You have data on some backend, whatever that is, whatever it's coming from the database, whether it has like in-memory structure or you're generating like fake data, it doesn't matter. It basically provides a query language for that data. You decide how the data will look like, but the query language is always the same. So it always follows the same specs when it comes to that. So, and it provides also a DSL to how you access that data. So for example, if you previously with REST endpoints, you had something like /API/employees and then some query parameters for filtering, that would look the same in this query. It would look like this if you were writing it in GraphQL. You would have a field called employees, which is parameterized by a filter, and the filter could have a bunch of things. For example, here we're filtering by first name, and then we get something back, an object or a list, and from that list we want only the ID, the first name and the last name, depending on whether the field returns a single object or an array. Only these fields will be selected from the subquery. These are like subqueries every time you go one level deeper. All right, so it's a query language. It's easy for GraphQL, and it's in the name, to combine relational data together in the single graph. So if you had previously with REST endpoints, let's say 3 REST endpoints, where one gives you the employees, and then you use the IDs from each employee to get their locations, and then from each location, you use the location ID to get the attributes. You could do that. You could do that with REST. It's no problem. I think many of us have already done. But the same operation, the same procedure would look like this query in GraphQL. And it's one query to get all of these related information in one go. So it makes it really easy to consume a lot of data in an expressive manner. Well, building GraphQL APIs itself is not straightforward per se, I would think, but from a consumer perspective, it's really nice. So a lot of front-end people, a lot of systems integration people like GraphQL, but the people who build it are not as happy. All right, so it's easy to combine related data into one graph, and it's also predictable. The things you get are the things that you ask for. So in the same sense that if you have a SQL query, you select a couple of columns from the table you want. If you want just ID and name from the table, you will just get that back. In the same sense, GraphQL allows you to, it defines what fields you can select, and then from each thing that is returned, you could say, I want just the ID, I want just the first name. And if it has a relation to another table, in this case, it's another field in the graph, like locations, you could immediately ask for fields from that location without having to manually map the IDs to the subtable and things like that. That's what the backend does. So from consuming perspective, we don't care about that. We just get the data we ask for. All right? And the best thing about GraphQL is that it's typed. There's a type system up front, and actually the type system is very close, loosely close to F#, I would say, because it has things that look like unions, like you have a book and it has a title and pages, and you can say whether it's a string or an integer. If you put an exclamation mark, it makes it required. No exclamation mark, it's optional. I say required, also non-nullable. They're interchangeable. If I use non-nullable, I mean required, and nullable is optional, whatever you want to, whatever terminology you prefer. And it has relations. So author here, the definition of author, has books. It is a list of, it's a required list of a required book. This is the explicit way of saying nothing there can be null. And here it's basically, it's just defining the relationship. It's not per se that this will be mapped to a relational database. It doesn't matter really. Like how the query is interpreted on the backend is irrelevant for the consumers. They just know when you have an author, they might have a bunch of books. That's it. And also really nice in GraphQL is that they have union types. So for something, when you ask for something, say search result, it can be one of multiple things, like a book or an author in the same thing. So when you for example have the field called search way below, which is the query object is the root object, and from there you can have fields. And here we have one field called search, and it returns a list of search results, each of which might be either a book or an author. So this is the GraphQL schema, and it's very expressive. It allows you to define these kind of things. And the way to use unions, well, I'm using unions because they're interesting in this case, but they're not very common because many languages don't know how to work with them, except F#. So here you have a search query, and you search for something like something that contains Shakespeare, and you actually pattern match inside of the query. So in the query you say, if my result is a book, then I want the title and the ISBN. Otherwise, if it's an author, I want the name, but I also want the underlying books from there. And from their books, I just want the title and ISBN. I'm also asking for the type name for other purposes. I'll show you in a bit. But the result of this query comes back from the backend as JSON. So this is how it would look like if I got actual results. So I get my first search result, which is a title and ISBN. I also ask the type name. I need that type name later for, well, type name is part of the GraphQL specs. Every object has a type name field that you can ask. But here, I need it later for deserialization on the runtime. Details. Yeah. So basically, this is how the data looks like, and we can do something about it. Now, it's interesting because it's an interesting problem, because when you talk about these queries, it is flexible, true, that the shape of the data returned is dependent on the input query, but that makes it difficult for typed languages, because if you wanted to write a type for each query, that would be a lot, because you cannot just generate a client for the entire GraphQL API. It has to generate a client just for the queries you wrote, because the shape of the input query dictates the shape of the output. So it's an interesting problem to work with. But for that matter, GraphQL has thought about these things before. They thought about, okay, how could we make this tool to be useful for developers? And one of the things about GraphQL, besides that it has a type system, it also metaprogrammable, and metaprogramming is very broad, I know, but in this case it means you can ask about the types in the schema. You can ask things about what you could do with it, right? So here what you have on screen is the standard introspection query, and you can send that to any GraphQL API, and it will inspect the types, the schema, everything that it can return. Not the data, not the underlying data from the backend, but the shape of the schema itself. So tools use this, Snowflaqe uses this, to generate types for specific queries. I will show you. So this is a standard query. You could run it against anything, and I can show you in a bit how that works. All right, so far so good. So many platforms are already started migrating their APIs into GraphQL, or just having both of them work side by side because they're so nice to work with. So GitHub, for example, does it. Shopify is one of the first e-commerce that started doing this. But I think the most examples that I've seen applicable to GraphQL are data access tools. So previously, a lot of backend developers would write the SQL code by hand, and it would require a whole backend to set up a front end, right? But what a lot of companies right now are doing, or these companies to be exact, like Hasura and PostGraphqL, they're saying, okay, don't worry about the backend. We will just take your database, whatever that is. We'll automatically generate a GraphQL API from it, so that the database is immediately applicable to outside consumers, like a front end, so that the people on the front end team don't have to worry about a backend that will be their backend, a Hasura enabled database, whatever that is. So it works like of course, everybody is panicking about security and how they do it, but it's well done. Like they do things with Auth0. You could authenticate on Auth0 and then use that to connect to the database, and I think it's well thought of, I hope. Okay, and otherwise we have also Amazon Web Services that are using GraphQL so AppSync is a nice example because they use something called GraphQL Federation, which means that if you have multiple schemas, multiple APIs, you could combine those into one and make it available from one API, which will branch out to other services if they need to, but the entry point, the gate API, is just one GraphQL schema. So that's what they're doing. That's really nice. Otherwise, okay, there's also some SMS solutions. We don't care. You can also spin up your own, of course. So on .NET, you have a bunch of options. You have GraphQL.NET. We're using that at our company. It is kind of okay. It's a bit low level. You have to explicitly define everything, but it has problems that are being solved right now with Hot Chocolate, which is another, actually not just a library, a platform of tools around GraphQL with C#. It is doing a lot of things good. They even have a code generation tool, but they generate C#. That's not what we want. And finally, we also have an implementation in pure F#, which I haven't tried before, to implement your own backend in F#. I haven't tried it, so I can't say a lot about it. Okay. So how to use a GraphQL API? Well, first I have one working locally. I can show you in a bit, but if you think about it, it's just an endpoint on some backend. It means you can use whatever you usually use to connect to HTTP to do that. So in C# or .NET, that would be HTTP client. You just replicate whatever you need to do. It's a post request to the endpoint with the query in the request body, plus some unnecessary details. So that's if you want to work with it from the application. But first, you start with what they call the GraphQL Playground. So I'll switch my view to this. Do you see it? Yeah. So this is, well, I wanted to have a nice API for demoing, and I didn't have data. So instead, I'm using a tool that generates fake data by allowing me to basically just write the schema, what I want the API to return, and then it generates the data for me. So basically, this is a really nice way to quickly make something or make changes to the schema and get the data right off the bat without any details. So let's see. Okay, I have it in here. I will run it up. Okay, running 5,000. It's running. It's opening up. Okay, so this is how the schema looks like. Oh. Sorry. Okay, so this is the schema, and I can write queries for it. So here, okay, let's go back to the schema to explain what it looks like. So here I have my root level query, and it has something, for example, one of the field is something called all companies, and it returns a list of company. And each company has an ID, a name, industry, and a list of employees. And then the employees have other things like I have first name, last name, but also a reference back to the company. And they also have, there's also a recursive definition here where you could also define subordinates. I don't know why they called that. This was an example, but subordinates in employees. So this is how the shape looks like, which means I could ask for, this is my query editor. I could ask for all companies. Okay. The nice thing about this is the GraphQL Playground. It's like a UI that works with any GraphQL API. And again, it's one of these tools that uses the introspection query to figure out what it can query from that API. So here, if I do control space, I get already intelligence about the API because it knows what is possible, what I can get from it. So here, if I have all companies, I start expanding it. And I see what things I could query from that. And I can go ID, name, industry, and I could run it. Now I get JSON back in this shape, because that's what I asked for. If I add more things, I will get a different, I'll get a different JSON. First name. Okay, so here we have companies, and each company has employees, and yeah, this is how it looks like. Of course, this is random, so it means every time I run it, I will get different data, but that's okay. We don't care. Okay, so that's how you work with it from the playground, but that's not how you would want to do it from your application. Like, okay, you're exploring the API, and you came to the conclusion that you made a really nice query, and you want to use that. How do you do that from your application? Okay, you can do that. You can set up like a text file, you could read from it and put it in the request body and call the API, but then you have to deal with the types here, and that's not fun to do it. So let a tool do that for you, and that's what I'm presenting today, a tool called Snowflaqe. So, so yeah, you start with the GraphQL API, you could move what you've seen to a HTTP client from C# or any other client, it doesn't really matter. But then you want to do more because these types are really annoying to work with. What you can use is actually a type provider in F# from the F# data GraphQL package, and it works. It works okay, except that it comes with all the problems that type providers bring along, such as that it generates classes and not records or unions. And when I built Snowflaqe in the beginning, I wanted it to support Fable. Fable is the F#2 JavaScript compiler. And Fable does not know how to work with classes if you do things like JSON serialization or deserialization and HTTP calls. So this type provider is not applicable to Fable, and that was my first use case for Snowflaqe. I needed to generate a client that knows how to run in a browser. So the type provider falls back. We also have a C# code gen, like I talked about, from Hot Chocolate. It's really nice, but it's C#. Again, can't use it for Fable. I think you could use that from F# normally. So I ended up writing my own, called it Snowflaqe, and this one does work for both .NET and Fable, as I will show you in a bit. All right. So a little intro to Snowflaqe before we get started. So it's a .NET CLI tool. It means you can install it like any .NET CLI tools, globally or locally. It's up to you. It's made for F# and Fable, and it does a lot to queries. I'll show you in a bit. And the nice thing about it, it does generate records and unions, and you need those when you map the types from GraphQL to F#. It also supports different async, like, okay, these are like very nice features later that I've added, which is, for example, if you have, when you generate the types, do you want async or do you want task? Do you want to generate a project file or not? If you want just to import the files, there's lots of options. You could change the serializer. If you don't like Newtonsoft.json, you could switch to system, and that will also work in case you're compiling for F#. So let me stop talking and actually start writing some code. All right. I have, no, not yet. So, okay, I have here my project, and it has this file called Snowflaqe. Okay, so this project is where I'm running my, my fake data generator here on the left. We will keep that working. And to work with it from a client, I will first start by writing a console app that reads the data and spits out a Excel file. So you start using Snowflaqe by installing it. So .NET tool install snowflake-g. And then you make in a directory like this, these configurations. I think those ones are the ones that matter. So first you say, where is your schema? What's the endpoint you're trying to connect to? You give it a path to the queries that you want to write. So I talked about that you want to use the playground to figure out the query you want. But after you've done that, once you've found a query, I want you to just copy-paste that query into one of those things, right? So you copy it to a file. You name it something like get all companies or get company by employee ID or get employee by ID. In this case, this is a parameterized query, which will translate into F# inputs later on, but we won't use that today. But it is supported. You could use that. So after you've said where your queries are, where the schema can be, okay, there are some more configuration, like what the name of the project should be, where the output should be, and of course that the target is F#. You could forget about this one. This is for details. So once you've done that, you could run Snowflaqe here, and by default, the first thing Snowflaqe does is type checking your queries against the GraphQL backend. So it goes out to the schema, downloads the schema, and checks that the queries are actually compatible before you even have to run them. So if I change something like industry to this, like if I had some kind of typo, it will tell me that this field is unknown because it was selected from this subquery of type company. It knows everything in the graph. It knows everything about how to check it. So it can find out about the small issues such as typos or maybe fields that are no longer there. But it can also figure out industry. It can also figure out some non-trivial things, such as if you used an optional parameter in a place where a required parameter is required. So this is it does the nullability checking quite well. So here employee expects a required ID, but the query itself is parameterized with an optional ID. So if I make it optional now, it should tell me that something is wrong indeed, because I used an optional ID in a place where a required one was expected. So it figures out these kind of things. I'm sure there are cases that I didn't handle with type checking. If you do find one, please report an issue. Okay, so after you run it and everything is good, all green check marks, you can say generate. And generate will, well, it first does the validation, and if everything is good, it will write out a full project. So this is different from a type provider. It will actually generate the full project and has a couple of interesting things. So first thing is that it has a client. The client will have a bunch of functions which will map to the queries. And each query will have the output shape in it. So for example, I have the all companies here. I have the all companies query, and the shape of the JSON returned is mapped to these types. So this query returns me data that looks like the following. It has the root query object, which has something called all companies of type list of company. And list of company has something that has ID, name, industry, and a list of employees. And employees have these things. Notice that the types generated are only the subsets of the subqueries I selected, because it can be different per query. If I had another query where I selected another field from another from another, from employee, for example, I just added another field, that's a different type. It's not the same type anymore. I don't think in F# we can say that this type is a subtype of another. There's definitely an improvement here where I could use fragments. Fragments allow you to reuse parts of your queries in your GraphQL queries, and that's not... Fragments are supported, but reusing them will just expand it out instead of making that a proper subtype. But that's okay, it's still very, very much usable. So these are the types, and then you have the GraphQL client, which does all the boring stuff like checking if it's an error and deserializing to the right type, etc., etc. It's not very important. So let's start using it. And by using it, I mean referencing the generated project from the project you want to use. So here I have a console application, and I'm referencing the project that was generated. And that in turn downloads all its dependencies and makes sure everything is good. The generated project is a Net Standard 2.0, which means that it's compatible for new .NET Core applications, but also for full framework apps if you needed to work with that. If you don't know what that is, lucky you. So for the Excel console, starting from nothing except for the reference, which means I could start using it. So this is a .NET, oh, not this one. Excel console, and then .NET Run. If you haven't seen F# before, this is a little F# console project. Actually, I could remove the usings, the namespaces, but you know, it's okay. All right, so while it's running and don't want to wait, so I'll start writing out what I need to write from the. So what I'm doing here is I'm creating an Excel file. I want to read the data from the GraphQL API and put out an Excel file. So I will open up the namespace that was added. So company data is the same name the project was. So if you define the project to be something, that's the name of the namespace. So I think that makes sense. And then you open up the namespace, you create a client, which is this one, and it takes, well, you could give it your own HTTP client if you want. But you could also just do this. So it's pointing out to GraphQL. And now we have a client. And client has things like these. So it has, from each query, it generated two functions, the asynchronous and non-asynchronous, and the synchronous one. I'm inside a console app, so I don't care about the asynchronous version. I'll just use the synchronous one. So get all companies doesn't have any inputs, which means it's just a function, takes unit. So what it returns, it's interesting. What it returns a result of either the query, if it was good. Otherwise, it returns a list of errors from GraphQL. So GraphQL usually returns errors if you had anything wrong in the query, for example. It's usually a list of errors, and the error have messages. Now, GraphQL has, I think here, a limitation because the shape of the errors are not part of the schema. There's no way to know what the error how the error shape will look like, whether it's a uppercase message or a lowercase message. You don't know. You have to make a wrong query. You have to get a syntax error or something to know how it looks like. And then in Snowflake, you could actually, there's a config to override how the shape of the error looks like if you need to. So that's that. So a list of errors, so either the data or the list of errors. And that's what each function is generating. Okay, I keep getting back to this one. I don't need it. So I have get all companies. It returns a result. It means I could start matching. So, okay, I'd say let response and then match the response with OK data. Start doing something with the data. Otherwise, you have error with server errors, which means you could do stuff. Let's not care too much about that for now. So here data, if I dot into it, I already see everything from there. So I have all companies because that's what I requested. So let's say companies is just like that, data, all companies, and then I need to make an Excel file. So closed XML, simple sheets. Small library on top of closed XML, which is a huge library to make Excel and Office files. So this is a nice API around it. Okay, let's make the file will be Excel create from companies. And it takes a list of fields that it needs to. So that is companies, Excel field from each company goes to, let's say, company name. Copy paste that one and say the industry. Okay, that's our file. Let's write it out. Write all bytes to companies.xlsx, I think, file. Okay, let's run it. And that should go out to the API and do stuff. Getting existential crisis. Okay, there you go. Companies. It's an Excel file. It's what's generated there. Okay, let me open that in File Explorer. Excel console. Companies. Hey, that will be the name of the company and its industry. So there we go. That was easy. That was not bad. But that's not very interesting. So let's do something more interesting with Excel. Instead of just generating those, we'll write some Excel functions. So I'll switch to Visual Studio. And I have something here. Oh, I already have it written out. That saves me some time. That's great. So I have here something interesting, I think. It's an Excel plugin, which allows me to write F# code, and that can be executed from Excel. And the nice thing about it is that it's as reactive as Excel is. So you can write functions that depend, of which the input is coming from cells, and if those cells change, then your function is re-executed to get data back in your Excel file. So here I have a function called hello, and it has a name, which means if I use that from Excel, I should be able to parameterize it. So what I have here, basically the same as what I had with the Excel file. I have a client here going on. So let me just start that off. Yes, so what it does, it builds the extension and it opens up Excel with that extension in there. So it asks me if I enable it, if I want to enable it or not. So I will enable it just for this session. Start with a blank notebook, let's say NDC Oslo. That's my input. And here I can say equals and then hello, and you can see it on screen. Tab, and then let the first cell be the input of that. And it says hello NDC Oslo. So it runs your F# code and generates, in this case, one cell out of it. If this changes, then your outputs also change. This is kind of cool for one cell, but the nice thing is that you can also generate a table from it. So basically the same thing I have as I had before. I call the client get all companies. The API looks a bit different, but you get the idea. We create a table from the companies and we create some headers, and from each header we define what we want to be the content of that header. So, and if we have errors, we will just output another table. Okay. So that would be equals companies, tab, close, and there you go. It used the GraphQL client to get out to the API, get data back, and show them on screen. Of course, because the data is always random, every time I click on it, it will go there and generate something. If I click on it, if I just re-evaluate again, it just generates other things every time. So it's kind of cool if you know you're working a lot with Excel, instead of having to generate files every time, you could just write an API that allows people to get data inside of Excel. So yeah, that's another place where this is used, and that's exactly why I needed this. So this is kind of interesting because the the Excel plugin is actually a full framework file. It's a full framework project, sorry, and it references a net standard project, and it works. But for it to also work properly, you need to set what is it called? The copy local file, local lock file assemblies. You need that to make it compile all of the dependencies to the output folder. Again, it's just boring details, but sometimes you need it, so it's there. Okay. So that's for F# and full framework. I go back to the original reason why I built this in the first place, which is to support Fable. So if we go to a Fable project, and here I have almost the same, except that this time I'm generating, I'm targeting Fable. Same queries, same project, but the generated code will be different. And here I have a simple React application that is rendering out the hello world. I'm not sure if it's open. Yeah, it is running. So we could go to localhost. Yeah, there you go. That's a React application written in F#, compiled to JavaScript. So if we go to components, we will change this, write something that gets the data from the API. So first thing I need to add, I need the company data. This is not the same project. I generated another project that is targeting Fable, so this is not the same one, but the same namespace, of course. So I need company data, but I also need some React goodies. I will use deferred hook. So let's say I have the company's React component, and that is a React component that has a client, which will be the company data GraphQL client. Now this one doesn't need to know the full URL because it's being proxied as if it was the backend. So just a path is okay. I have the client. I could get the response, which is React hook use deferred, and deferred will take something asynchronous. So that's client dot get all companies, and this has no dependencies because I just wanted to run it once when the component initializes. So I have response, which is a deferred of whatever that asynchronous function returned, and a deferred means that is something that is gonna give me results after a while. So I could check if it has something, then render that out. So match response with deferred, and if the deferred was resolved with some good data, we can start doing something with the data. Data all companies, and then we have something that we can render out on screen, which is HTML unordered list for company in companies, do HTML list item company name. Okay. If I have anything else, then I will just assume anything else. I'll just assume I'm loading. You can handle errors separately if you want. Like there's a resolved error and then failed. You could for each case you could define what you wanted to return. Okay, so this looks kind of okay. It's rebuilding. Hello world is no longer a component, so I need to change that into companies. Okay, recompiled everything, and there you go. It went out to the backend, got the data, deserialized it, and then rendered it on screen. Every time you run it, it will just get the random data from my fake API. All right, I think that was it for the demo. I do want to take a quick look at the repository itself. So Snowflake, well, not the issues. Oh, well, that's unfortunate. I wanted to show you the options that there are in Snowflake because actually I could do that from here. So I have it running. Go back here, go back to the schema, and I already showed you the union, so I want to show you how that looks like when you generate it. So if we had, let's also call it search results. So union search result equals either employee or company. So that's the union that is returned from something called search. And we won't parameterize it, it doesn't matter because this is random data, it will generate something for us anyways. So this returns a list of a required search result, and the list itself is also required. So that's nice. We can save that, go back to our queries, and then instead of, we have search, and then we do the pattern matching we did before, like ... company. If it was a company, then I think it's on company. Yeah. On company, I want ID, name, industry, but I also need the type name. That if it was this, and on employee, I want ID, first name, last name. So this kind of works. Yeah, it still generates some things. So sometimes it generated, okay, for employee, I also want some type name. Okay. So it will get back the type name and the company in the same output result. I'll take that, go back to my project, go back to queries, add a new one, search GQL, add the same query here, and run Snowflake again. Well, first check out that it works. Like for example, if I do not add type name, it will tell me. It should tell me after I save. Yeah, it's not in the right repository side. Okay. So yeah, it tells me that you need type name. It's not necessary for code generation, but it's necessary for the runtime, because the way that the types are discriminated upon is using that is the type name field. So Snowflake generates, and from this enum, well, which is the subset of the original type, it should generate a full enum in F#. So if we go to search fs, that is the type that it generated. So it knows that it has to return a search result, but this is like, again, a subtype of only the things that you selected. So we did do the pattern matching from the GraphQL query, but from employee, we only selected a couple of things, and the same for the company. We didn't select all the things, so it knows that it only needs to compile just the things that were generated, and it gives you a union, just like you would expect in F#, and you can pattern match over it and do everything you want to do with it. So yeah, this is one of the cool things that are enabled. There's also interfaces. It also supports interfaces which they compile down to unions. So that's nice. They're just supported if you need to use them. All right, so that was a little bit of the demo. Yeah, we've gone through everything. Of course, some things are still missing from Snowflake. Like I talked about, the fact that you cannot reuse fragments across queries. You could just reuse them in a single query. They will be expanded out to the way you use them. And there's no subscription support. So in GraphQL, you have subscriptions, which are real-time mechanism where you could do WebSocket with them. They're not supported yet, just because I didn't have a good use case for them. But if you do have a good use case, just file another issue. And with that, we've shown the demo. We have a couple of links here. I'll share the presentation later on Slack so that you could have access to all these things. So the project that allows us to build the Excel functions is called Excel DNA. It's really cool. It works with .NET. So it's not F# specific, but it's kind of cool that you could use it from F# to build those things. I made a specific template if you need to start with writing those plugins if you want. And I've made a playlist on YouTube for Snowflake if you want to get more details into what I've done today. with that, one last thing I want to talk about is that every time I show this to people, they ask me, okay, what about Open API? What about RESTful APIs? Is there something like that for them? And yes, there is. It's the Hawaii project that I built this year. It works. You could give it a try. I'm sure it requires more testing, but I'll leave that to you. And with that, I think I can wrap up. Would love to hear from you if anyone has any questions. Yes?
You use both Visual Studio and Visual Studio Code in your demo. Could you manage all this just with one of them?
Yes. So I use Visual Studio because of the following. So if I go to Properties here, yes, I could have done with Visual Studio Code, but I had to set up the debug arguments for my project. So what happens is that, okay, if it opens up, the debug arguments are that it has to run Excel in the path, and it gives the generated Excel DNA back as input for Excel. So after building, it's like a post-build event that it runs Excel with the generated Excel. It was built in the template, so I didn't have to I didn't have to do that in Visual Studio because you would need to make like a debug configuration thingy. But I could have definitely just used Visual Studio Code. Yes.
When using Snowflake, would you recommend to run Snowflake during development and checking in the generated source, or as part of the build step?
It could be both. It could be both. You definitely want to use it in development time, and that's like the base use case for working with it. Instead of having you to write the types yourself, you could just let Snowflake do the rest and commit the generated code to your repository. That's totally fine, I think. But again, if you want to every time make sure that the backend you're typing against still works with your queries without having to do the generation, at least just the query validation, I think, would be a valuable step in your pipeline. You could say, just validate my queries, make sure that the types that I'm getting back are the same and they don't need to be regenerated again. You could also do that as a pre-commit hook, just to make sure. I think the base case is already usable for that. Actually, for Snowflake, there's also a project called Snowflake Tasks, which has MS Build integration that allows rebuilding the project and regenerating it when needed. For the as a post-build event, and not just manually. I don't use that yet a lot. A couple of users do. So and they're like still working on the basically. That has some rough edges, so they're working on it, but when it's fully implemented, I will document it properly. So for now, just use the CLI, and if you need to automate it, you could also add another step in your build script to either build or validate your queries. Yes?
Fantomas comes with the Fantomas -- check that you use on this in the CI system just to make sure the code formatting is the same.
Yeah.
Snowflake just have a -- check that gets done as the CI step.
It's like the default Snowflake command actually does the check. So unless you do -- generate, it will generate, right? So it does the validation. It does the validation by default. But if you want to say, the problem with validation is that when you validate against an online service, you don't know that it will be online, and you don't know, and like maybe you don't want to run it from your CI because maybe it's your project and you can't run it on CI to test against it. So what you could do actually in the schema, where is it? The schema configuration, I didn't tackle this, but schema doesn't have to be a URL. It can be a relative path to a file that contains the output of the introspection query of some schema. So that's like offline mode if you want to validate things offline. So what you could do either, like again, before you commit your code, you could regenerate the schema from the external backend you're trying to work against, so that the CI only works against the offline files instead of having it to go out to the API itself. Yeah, check out the options in the on the Snowflake repository. There's a lot of them. I didn't cover all of them here, of course, but you can see what you need there. Yes?
Yeah, you said that it was kind of painful writing the kind of backend API for the GraphQL.
Mm-hmm.
Do you know of any tools that could help kind of make that process a bit simpler?
Yeah, so I think, well, you have these tools that auto-generate what you need to do. So if it's just a database, maybe you go for Hasura or PostgreFile that automatically generate everything. But if you're on .NET, for example, I know that Hot Chocolate is fixing a lot of the problems that the lower-level GraphQL.NET has. So I think checking out the Hot Chocolate one will be nice, because they have really nice plugins when it comes to, like, if you have an entity framework project, you could just hook up one collection and say, okay, make this a GraphQL field, and they automatically generate like the relationships and the filters and everything from GraphQL. So they're doing really good stuff.
On subscriptions, like, do most GraphQL server-side implementations actually support subscriptions and incrementality, or is it?
No, it depends. Like it's basically, without having you to implement it separate from your application, it's kind of part of the same API. So if you need anything that has to do with real-time communication, is done through subscription, so that it follows the same GraphQL schema, so that it follows the same workflow of whatever you're doing, but the runtime is different. So the queries themselves, with the runtime we're using here, is a basic HTTP, make a post request, deserialize the results. But if we needed subscriptions, then the runtime will have to set up WebSockets to connect to it. It's all spec'd out. It's just not implemented yet. But I don't think it's common, at least not in what I've seen.
And the subscription gives you an incremental view of the results of the query. So it'll tell you there's an incremental add, obviously, of a top-level result, but it would also tell you if, like, one particular entity had one particular extra result added or something like that.
I think I think the way it works is that you have a subscription query. It looks like the normal queries you have there, and then you will get an observable that says, okay, you have a new value of that type.
Okay.
You could subscribe to that observable.
It was more about, like, what happened if there's an incremental change to one of the nested fields.
Oh, I think you just get the whole thing on every event. Yeah. Anything else? Well, I guess then we can wrap it up. Thanks again for coming, and thanks for having me.